Hello, fourth grade. How are you? Today we are going to try to match our understanding of multiplication with a new concept of division, specifically long division. You're going to need page 30 in your prime for a book. So let's get started. As you know, division and multiplication are very similar. We can actually find the reciprocal of a division problem with its multiplication numbers. So for example, if we look at this first problem, which says 5 times some number gives us 35. Well, if we know our multiplication tables, we can just put 7 in that blank, right? 5 times 7 is 35. So since we know that, we can also find its reciprocal. Our final answer for our product is 35, so 35 divided by 7 equals 5. The same concept goes with this. So say, for example, we take 7 times 5, which also equals 35. We can divide 35 by 5, and that'll give us 7. So similar to this problem, all right? Multiplication is very similar to division in that way. So as you can see, the division and the multiplication have the same factors. We're using the same exact numbers. All right, what I'm going to do now is we're going to actually go to page 30 just to understand that a little bit better, okay? We're going to do some multiplication problems, and then we're going to do some division problems. As you can see on the board, first we're going to multiply 4,032 by 3. When we multiply 4,032 by 3, we start with the ones place, right? 2 times 3 is 6, and then we go to the tens place. 3 times 3 is 9. Hundreds, 0 times 3 is 3. You'll notice my numbers go right below my problem. My answer blank is right next to, in line with my problem. And then 4 times 3 is 12. We're going to put a 1 over here and a 2 down here. Okay, that was pretty simple. 12,396 for number 2A on page 30. Let's do letter B. When we do letter B, we're doing the same concept. We are just taking our ones place first, so 0 times 5. Any number times 0 is always going to be 0. 5 times 7 is 35. If I didn't know that, I could look over here on my trusty multiplication table, and that'll give me my answer, right? 5 times 7 is 35. My 5 goes on the bottom, and my 3 goes on the top of my next column. Now what we're going to do is multiply 3 times 5. 3 times 5, let me change the colors so you guys can see this. 3 times 5 is 15. But what I need to do is add that number, which is on the top, to get the number in my answer blank. 15 plus 3 is 18. So I'm going to put an 8 on the bottom and a 1 on the top. You'll notice what I just did is I took 3 times 5, just like this, and then I took my answer and added the previous problem, okay, the previous steps number that was on the top, right, that 3. So 15 plus 3 is 18. Now 2 times 5 is 5 plus 1, which you can see on the top, right? You can see that 1 right in the top. 2 times 5 is 10 plus 1 is 11. So our final answer is 11,850. All right, why don't you do problem C and D on your own, pause the video, and then check your answers. All right, hopefully you paused the video and you're able to check your answers now. Let's go to number 2C. 8 times 9 is 72. So I'm going to put my 2 on the bottom and my 7 on the top. Let me just erase this just so that we have a little bit more space. 9 times 8 is 72, just like I just said. We put our 7 on the top. Now, 0 times 9 is going to give us 0. But we need to also add that 7 on the top. So 0 plus 7 is 7. I'm going to put my 7 down here. All right. 2 times 9 is 18. So I'm going to take 2 times 9 next. 2 times 9 is 18. And we don't have anything to add, so we're just going to put our 8 on the bottom and our 1 on the top. 3 times 9 is 27. If I don't remember that, I can always go back to my trusty multiplication table and find that out. 9 times 3 gives me 27, and I'm going to add that 1 on the top. 27 plus 1 equals 28. So that's going to be the last step of my multiplication problem. 28,872 is my answer. All right, let's do letter D. Let's check that one. Well, just like in the previous problem, I'm just going to erase this so we have more space. 8 times 6 is 48. So what I'm going to do is take my 8 and put it on the bottom, and my 4 goes on the top. Just like the previous problems, 4 times 6 is 24, and then I'm going to add 4, which equals 28. My 8 goes on the bottom, and my 2 goes on the top. Let me change the color so you can see this. 2 times 6 is 12, plus 2 on the top equals 14. My 4 goes on the bottom, and my 1 goes on the top. And my last problem is 7 times 6, which is 42, and 42 plus 1 equals 43. Can't really see that very well. Let me write that again. 42 plus 1 equals 43. So 43 is my last step of that multiplication problem. My final answer is 43,488. If you have any questions about these problems, please let Mr. Joseph know so that we can continue to practice the multiplication. I'm going to delete everything on the screen, and we're going to go to the next page. This next page is exactly like we just did, but this next part of the page is relating multiplication to division. So let's actually make this a little bit bigger just so you can see it. When we relate multiplication to division, basically what we're doing is taking our factors, multiplying them together, and finding our product. Now that product can now be called the dividend. A dividend can be divided by one of its products by one of its factors to find the other factor. In this case, we're going to call that the divisor and the dividend. Okay, the dividend in this case is the larger number, which we're then dividing by the divisor. Okay, so let's look at a couple of examples. If we divide 16 by 8, we get 2. And if we divide 16 by 2, we get 8. You'll see that those are all reciprocal. Multiplication relates to division. So in this example, for example, we have 250 divided by 6. Well, we're going to see how many times 6 goes into the first number. That first number is our 2. Well, 6 times 0 is pretty much the closest number that comes close. Okay, it's going to be a decimal, but we're just going to put a 0 on the top and go to the next number, which is 25. Looking at our multiplication table, what number comes close to 25? Well, 6 times 4 is 24, so that comes close without going over. We're going to put our 4 on the top. 6 times 4 is 24, and then we're going to subtract. 25 minus 24 equals 1. The next step is bringing that number in our problem, okay, down to the next step of our problem. So bring down our 0, and now we're going to see how many times 6 goes into 10. 6 goes into 10 just one time. So our answer is approximately 41, with a remainder of 4. Okay? These problems are very similar to the ones that we did on page 29 in your prime book. Okay? So let's actually look at page 30 and do a couple of problems together. On page 30, you will see that we are dividing our first problem by 4. Okay, so we're going to be looking at our 4's tables. Let's actually look at that right now. With our 4's tables, we have 4, 8, 12, 16, 20, 24, 28, 32, 36. Okay, that goes all the way up to 9. So let's see how many times 4 goes into our first number. Well, our first number is a 5. And I know that 4 goes into 5 just one time. So 1 times 4 equals 4. Now I'm going to subtract. 5 minus 4 is 1. All right, we're finished with our first step. Now what we need to do is figure out which number is going to be brought down into our problem. That number is a 2. So let's bring that number down. And let's see how many times 4 enters 12. I like to write it like this. 4 times what number, in other words, what number in our answer blank, right there, is going to equal or be close to the number 12. Well, I know that 4 times 3 equals 12, exactly 12, so then we can just subtract that. All right, 4 times 3, like I said, is equal to 12, and we can go ahead and subtract. 12 minus 12 is obviously 0. All right, what do we do next? Well, we bring that next number down into our answer, okay? It's almost like our remainder. We're bringing the remaining numbers into our answer, okay? How many times will 4 go into 0? Well, 0 times, right? 0 times 4 equals 0. All right, our last number is an 8. So let's bring that number down, bring our 8 down into our problem. And let's see, how many times does 4 go into 8? Well, it goes into it exactly 2 times. 4 times 2 is 8. So there we go. We put our last number in our problem, and our answer is 1,302. Let me just make sure. 8 minus 8 is, that's a 0. Okay. As long as we have a 0 as our remainder, we are completely finished. We worked on a couple of problems last week on finding remainders in our answer, but this week we're going to do a little bit longer division, and we're not going to have any remainders on this page, okay? What I'm going to do is do the next problem. Let me just erase this part of the problem so you can see it. All right, and this time we're not dividing by 4. We are dividing by a different divisor, which is 3. Okay, so let's look at our 3's table. We have 3, 6, 9, 12, 15, 18, 21, 27. Those are all of our multiples of 3. So let's see how many times 3 enters our first number. Well, our first number is a 9, and I know that 3 times 3 equals 9. Now we subtract, just like the other problems. 9 minus 9 is 0. I'll write that again so I have more space later on. I'm going to bring my next number down. My next number is a 2. How many times does 3 go into 2? 3 times what number comes close to 2? Well, it's not 1. It's not 2. It's got to be a number that's smaller than 1 or 2, so that is 0. 3 times 0 comes close to 2. Okay, so we're going to put our 0 in the column, put our 0 right there, and subtract. 2 minus 0 is 2. Let's bring our next number down. Our next number is a 0. How many times will 3 go into 20? 3 times what number is approximately equal to 20? You'll notice I'm using a squiggly equal sign. That means approximate or estimate, which we've learned before in the past. Well, if we look at 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18. Oh, and the next one's a 20, so 21. So we would go over, so that's actually 6. 6 times 3 is going to give us the number that we need. All right, 6 times 3 is 18. Let's put our 6 inside of our answer blank. And let's subtract 20 minus 18. 20 minus 18 is 2. And then I'm going to bring my next number down. My next number is a 7. Now we need to see how many times 3 enters 27. 3 times what number equals 27, or comes close to it? Well, if we look at our multiplication table, we can find out that 3 times 9 equals 27. Our 9 goes in our answer blank, which is very important, and 27 minus 27 equals 0. So our two answers that we have for these two problems, I'm going to put in a yellow box just so you can see them. Our first answer is 1,302, and our second answer is 3,069. Now, if I wanted to check these, I could check these on the calculator and multiply, just like we did before. So let's actually do that. I can find the reciprocal, right? So let's do the first problem. Our answer, which is 1,302 times 4 equals 5,208, which is our original number right there. Okay, so we did that one correctly. Let's check the next one. 3 times 3,069 equals 9,207, which is exactly the same as our original problem. So we did this correctly. If we wanted to divide it to check it, we could divide too. 5,208 divided by 4 equals 1,302. And our next problem, 9,207 divided by 3 equals, oh, let's try that again. I don't think I did that correctly. 9,207 divided by 3 equals 3,069. Perfect. So we did that exactly correct. Awesome. Let's do the next problem. Letter C. So I'm going to erase everything on the screen, and let's go to letter C. Letter C says 1,936 divided by 8. Let's try this. With this problem, we are trying to see how many times 8 enters our number. So let's look at our 8's table. So we have 8 right here. Let's look at our 8's table right here. 8, 16, 24, 32, 40, 48, 56, 64, 72. Those are all of our multiples of 8. 8. Can 8 go into 1? No. Can 8 go into the next two numbers? In other words, 19? It sure can. Yeah, if we look, 8 times 2 is 16. That's the first number before going over, right? So 8 times 2 is 16. So what I'm going to do is put a 2 right up here. All right, and I'm going to put it in my second column. Okay, you'll notice that I'm skipping over to my second column. I'm going to put my 2 right there. If you wanted to put a 0 right here, you could, but it's not necessary. It's optional. So I'm just going to skip it. 2 times 8 is 16. So let's do our subtraction. 16. 19 minus 16 is 3. And I'm going to bring down my next number. All right, 8 times what number is approximately 33? Well, if we look at our multiplication table, I see that 32 comes very close. 8 times 4 is 32. So this is pretty close to 33. 32 is the closest it comes without going over. So we're going to subtract 33 minus 32, which gives us 1. I forgot something very important, which was to put my number in my answer blank. 4 times 8 equals 32. Now I knew that because I was going to bring down my next number and I realized I had nothing in this column. So make sure you don't forget to put your answers in those columns. All right, let's bring down that next number like I was going to do before. Bring down my 6. All right, 8 times what number is approximately 16? Well, we don't even need an approximate this time because it's exactly 2. Okay? 2 times 8 equals 16. We subtract just like normal and we get 0. So our final answer is 242. If you wanted to check that on the calculator, you could, but it doesn't really matter. All right, what I'm going to have you do is do this problem on your own, and I will give you the answer next time, okay? I'm not going to give you the answer in class right now in this video. I would like you to do that division problem on your own so that we can check the answer for next time. So basically what we're doing is 2,520 divided by 7. So what answer are we going to find? Okay? What we're going to do is I'm going to, where did my little box thing go? I'd like to erase everything on the screen, but I can't find the box. It's hidden somewhere. I'm going to show you a game, okay, that I would like to play, which is the division game that we can use to practice, okay? But I would actually like to. it's it's right here, but I can't get access to it. So for some reason, there's a block, but that's okay. I will show you the division game next time. But I'm glad that you were here in class today, and we will see you next week.